All right, calculations in Anova. Yeah, this is where we start to get a little more complex. Not much more complex than regression, but we've got some added complexities here. So calculation of Anova. What I'm going to do is I'm going to focus on this article. It's kind of an older article, but I really like the approach that they used. They examined in this study strategies to increase intentions to use condoms. And they recruited sexually active college students for what they were told was a study on HIV and AIDS prevention. I'll tell you about the study in some detail and why I think it's cool in a sec. This study was conducted by Jeff Stone, who's a professor of psychology at University of Arizona. Why am I showing Jeff Stone? I usually try to use this space to highlight the work of BIPOC scholars. However, Jeff is very interesting. He got his bachelor's at San Jose State, his PhD at UC Santa Cruz. But what makes Jeff interesting is that he's a native of Eureka. He's up here every summer. He's given talks for our department. Really engaging speaker. All right. So as an example, students who were randomly assigned, for this example, I should say, students are randomly assigned to do one of four things. So you come into the lab, you're told one of these things. In the first one, people were just told to, they needed to read some information about safe sex. And this is what's got called the information only condition. In the second one, they were told they needed to read the information and then prepare to give a short video presentation on safe sex. They were told that this would be used across campus in a safer sex campaign. This was called public commitment condition. The third condition, they gave the videotape presentation and they privately listed situations where they had failed to have safe sex. They called this the public commitment private failure condition, or the hypocrisy condition. I'll talk about that condition more in a second. And then finally, they had a condition where they just read the information and privately listed situations where they'd not had safe sex. What the researchers were working with, they were working using a theory that you probably learned about in intro psych called cognitive dissonance theory. How you're motivated to change your behavior when you are confronted with conflicting pieces of information. You're giving a public presentation about having safer sex and then being forced to recognize situations where you failed to do what you're telling people to do. That creates that hypocrisy, and that the authors believed would motivate people to have a greater intention to use condoms in the future. So I have to give a little bit of context for this. This study was published in 1996, which means that it was probably conducted in 93 or 94. Back then, I was in graduate school, and we weren't in the era of free condoms yet. You would have to go to the student health center and buy them, not for a lot of money, but it was out of the way. At the UC Santa Cruz campus, you could be in one dorm and the student health center could be nearly a mile away. So we're talking a considerable distance. So at the end of the study, the participants got $4. And the experimenter then said, okay, AIDS Education Center sent some condoms and pamphlets on AIDS when they heard about our prevention program. They wanted to give you an opportunity to buy condoms for the same price that they're sold at the health center, 10 cents. This way you don't have to go across campus and stand in a long line. The experimenter then explained they had to leave. If they wanted to buy condoms or take pamphlets, there was change in a dish on the desk so that they could make change. The measure of condom use intentions here is the number of condoms that they actually purchased. The researchers came back after they left. They're like, okay, well, we had 45 condoms before. Now we have 30. They must have purchased 15. So they're using that as a measure of intention to use condoms because they can't go follow them back to their dorm rooms and see what they're doing. So here are some data that kind of mimic the study results. We see the information only condition. There's 4 participants. Their purchases are 4, 3, 3, 4 for a mean of 3.5. You can see across the board, we've got the different mean values. Our big question at first is, okay, are there differences between these means? So to calculate the sums of squared total, that's our starting point, we're going to take each individual score and subtract it from the overall mean, which happens to be 3.5. So we do that. Sweetie, yeah, okay. All right, I'm sorry. So sum to square total. My children just have no understanding that I'm recording and shouldn't be interrupted. Anyway, so we do this for every single score. We subtract from it the overall mean, or the grand mean, which was 3.5 in this case. Just a coincidence that some of the groups have the same grand mean as the the overall mean. You can see that this comes out to 26. This is something we actually did with regression, same approach. Next up, sums of square between groups. Sums of square between group has this shortcut built in, because you can take the number of people in each group, multiply that by the mean of that group itself, minus the overall mean, square it. So we do that for each of the 4 groups. So this calculation is actually a little shorter than the others. And we get a value of 18. Now, looking at this, we know, okay, between and within have to add to total. We could just say, okay, well, within must be 8, but you know, we only calculate 1 or 2 of these by hand. So it's useful to do all 3, because if you got one wrong, you're gonna have all of them wrong. All right, sums of square within. With sums of square within, we're taking the individual score minus the mean for the group that they're in. So for the first 8 scores, you'll see we're subtracting 3.5, because the mean for the information group is 3.5. The mean for the public group is 3.5. For the next 4 scores, we see 6 minus 5, 6 minus 5, 4 minus 5, 4 minus 5, all of those squared, of course. The next one's 2 minus 2, 2 minus 2, 1 minus 2, 3 minus 2. Again, each individual score minus the mean in the group, and then we square that. We add that up, and it does indeed come to 8. All right, once we've got these sums of square values, most of the rest of the calculations just involve dividing one thing by another. All right, what do we do next? Well, we need the mean square, and for the mean square, we're going to need the degrees of freedom. These, maybe I should have put them in a different order. Let's do the degrees of freedom first. So degrees of freedom between group, that's the number of groups, 4 minus 1, so we get a 3 there. To get the mean square, which is just the average sums of square per group, average sums of square per degree of freedom, I should say. We have sums of square between, which was 18, over degrees of freedom between, which was 3, for a value of 6. Again, this part of the calculations are pretty straightforward. For the mean square within, we need the degrees of freedom within. The degrees of freedom within, I'm sorry, it's not listed there, it's n minus j, the number of people minus the number of groups. There were 16 people in 4 groups, so that gives us 12. Then the mean square there is 8 over 12, or 0.667. Finally, to get the f value, we take our mean square between over our mean square within. 6 over 0.667 gives us a nice round value of 9. Our null hypothesis, again, is that all of the group means are equal to each other. Now, rejecting the null hypothesis doesn't mean that they're all unequal. It means that something in that statement is incorrect. We know, for example, that mean 1 and mean 2, they were exactly the same thing. So those are, those would have no evidence to say they weren't equal. All it means is something in that statement, something is unequal. So we could do it the old-fashioned way and go to our F table, match up the degrees of freedom to the F value. The cutoff F value is 3.49. If we were using that approach, clearly 9 would be greater than 3.49. We're, of course, not going to use that approach. We're going to instead, oops. If we were using that approach, that's what that would look like. We won't use that, or I'll show you a different approach that is more preferred in a second. We also can calculate the eta squared statistic. Again, just taking sums of square between group in the numerator, the denominator this time is sums of square total, and it gives us 0.692 for our effect size. We talked a little bit about the F table. We're not really going to work with the F table. You can see our cutoff there, and our value is 9, way, 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 way above the cutoff. Well into the reject region. Another way that we could do this is we could use this one tiny bit of code that's in the lower right-hand corner from R. 1 minus PF. The 9 refers to the F value. DF1 is the first degrees of freedom, usually the smaller one. 3, DF2 is 12. So there's the between group and the within group. One way you can think about that if you're having a problem remembering is it's the smaller one and then the larger one. And we can see the probability is 0.002, well below that 0.05 criteria. So again, reject the null hypothesis here. All right, in terms of interpreting the effect size, like with R, we interpret this as proportion of variance explained. So the research condition here explains 69.2% of the variability in condom use intentions, just like we interpreted in regression. Taking a look at this in R, a couple new commands here. The tapply command is useful for getting means across groups. You can see I've got, the first thing I list is what we're getting the means for. The second thing is the variable that breaks them into groups. And then the last one is the statistic that we want. We want the mean statistic. I could have put in standard deviation here as I did in the second one. If we look at the next piece, we've got the Anova. I'll show you the code for this inside the tutorial. I may have missed that here. I'll show you that piece later. We see with Anova, we've got our degrees of freedom, our sums of squares, our mean squares, our F value. This doesn't give us the total sums of square, but we can easily get that through addition. And then down below, we also have an effect size, and I'll show you again in the tutorial how you get that effect size. We use a specific package called LSR for doing that. Here's a nice example of how you might write this up in proper APA style, something that's a big focus of the Psych 242 research methods class. Kind of one of the biggest pieces in that class is learning to write in this style. You can see the public commitment, private failure condition. I give the mean and the standard deviation. Notice that those are italicized. That's part of the format. Produce more condom purchases than the information, public commitment, or private failure only conditions. Then I present the F statistic, also italicized, 3,12, those are the degrees of freedom. It equals 9, and then I provide an exact probability, also italicized, and an eta squared value, which is not italicized. That we don't italicize Greek symbols for some reason in APA style.